Hello, future programmers. I am Dr. Ron England, and this is a video that I've made for my class, Programming for Engineers. But we just want to actually, at this point, talk about programming. And when we talk about programming, we talk about the fact that a lot of people really struggle with programming. And part of the reason is because in programming, you got to use a programming language. And all these people are like, well, why can't we just use good old English? Well, the reason we can't use good old English is it's vague. When you're telling a computer what to do, you need the computer to do exactly what you tell it to do. There can't be any nuance or anything like that that says, hey, I don't actually know exactly what it is you want me to do. The computer needs to know exactly what it is you want it to do, because it's not going to make a decision based on its own personal experiences of what you might actually mean. And the reality is you don't want it to. So let's talk a little bit about programming. Now, in the world of programming, you got a few basic things that programs do. And from these simple things, you can build amazingly complex programs. But if you look at it this way, everything on the computer in the end is simply a Turing machine. If you don't know what that means, look it up. It's all ones and zeros when it all comes down to it. Binary, true or false, 0 or 1, positive or negative. And from those zeros and ones, you can build amazingly complex structures. Just like when you're talking about DNA, you can make amazingly complex things like human beings. Okay, but in the end, it's just this. It's whatever you got put together. Almost like ones and zeros. So in the computer programming world, you got these basic concepts, these things that you do that computer programs all do. And all the other pieces of computer programs are kind of put together with these concepts in mind. So here's these concepts: variables, conditionals, loops, and functions. Let's talk about them. Variables. Okay, variables are good. Variables allow you to take something. Now, in the case of computer programming, you typically define a variable, and you define it with a name, like y or x or a variable or something that has its name, and you can assign it to other things. And that assignment can change. So you can set it to values. You can set variables equal to other variables. You can use equations. Now, we haven't talked about functions yet, but functions return information which can then be set to a variable. So my variable y here is being set to all sorts of other things. Now, in different computer languages, you need different ways of declaring these variables. Some of them would say let y equal 6, use let, or var y equals 6, or int y equals 6. In the case of int y equals 6, you're actually saying y is going to be an integer. You're telling it what it's going to be, not its value, but what type of thing it's going to be. That's called typing. Not typing like on a keyboard, but establishing the type that a variable must be. So we've got this ability to define these things. Now, if you, taking this course, have had calculus, this should not be above and beyond you, because this is used in calculus. It's used in algebra. It's a basic mathematical concept that you should have. So let's talk a little bit more about these variables. Now, first things first, variable doesn't have to be a number. If you think of it as a number, that's great. But the reality is it doesn't have to be a number. It can be text. It can be something way more complex than text and numbers. It can be a combination of text and numbers. We call those objects, sometimes classes. There's these different things that it can possibly be. But it can be numbers. And we can also say that it can be different kinds of numbers, like integers and floating point numbers are different kinds of numbers. They have different behaviors, and it can be one of those. So with a variable, in some languages, you don't have to tell what type of variable is. In other languages, you do. So like in some languages, you have to declare your y to be an integer, and it can only be an integer from that point on. That's all it's going to be. It's an integer. It stays an integer. Or it can be a floating point arithmetic number, something like 5.7 or something with a decimal place. Or a string. Strings are our computer programming name for pieces of text. We've also got chars, characters, which is a piece of text which is a single character. But I tend to use mostly strings. And you may use a char, but there's other kinds of variables. There's other things besides here. They're the ones that I showed you, int, float, and string, but those are the three you're probably going to use the most, ints, floats, and strings, because they're the most useful. So that is one of the main concepts of programming, that concept of variables. Now, the concept of a conditional, you would think, oh God, how hard can it possibly be? A conditional. Conditional is simple. If something is true, then do something. I got some examples here, and if you look at my examples, you'll notice that the syntax is very specific. Like if y equals 6, then print 6. But notice that it's not y equals. Y equals 6. Why do I have the equal? Because in the last example I showed you where you assigned a value to the variable y, the equals was the assignment operator. It assigned a value to a variable. Well, assignment doesn't necessarily have to be the exact same as checking for equality. So in the case of checking for equality, we use the equals. Now, that's true in some languages. Some languages, the single equals works just as well for assignment or equality, okay? Or checking for equality. In some languages, it does not. That's going to get you into the concept of the syntax of the language. But the concept is assigning, just because you've used equals in your life up to now as both a assignment and a checking, doesn't mean that the computer is capable of doing the same thing, because they're different concepts. Assigning a value to something is completely different from the concept of checking to see if it is equal to something. And in some computer programming languages, you use a different operator to do that. And that's what's happening in the example that I showed you there. Okay. The language that you're using is going to have different syntax. And I recommend that if you are using multiple computer languages, or you just need to know what the syntax is for those computer languages, you either have two ways of doing this. One is look it up, or you can memorize it and just know it by heart, which most programmers will typically do. Or you can have your little cheat sheet or your little card that tells you the syntaxes of different languages. Either way, the concept in every language is the same, which is why when somebody comes to me and says, well, how hard is it to learn C#? I'm like, as hard as it is to learn every other language, because the concepts are exactly the same. And a programmer never says, oh, I can program in C# or Visual Basic or Python. They say I can program, because it doesn't matter what language is thrown at them. They know how to program in every language, because it's just a difference in syntax. It's not even a difference in language, because all the languages do the same thing. It's a difference in syntax. But syntax is important, because if you don't get your syntax right, one of two things is going to happen to you. You're either going to get an error, okay, or it's not going to do, the program's not going to do what you expect it to do. So, learning how to check your syntax and being able to have the references you need to do syntax correctly is truly important. Well, let's go on to the next thing that we've got here. Loops. Loops are wonderful. Loops are great things. Loops basically say, keep doing something until I tell you to stop. Or do something this many times and then stop. Wow. That seems pretty basic stuff. Now, of course, you need a syntax for doing loops. Like one of the syntaxes that's often used, which we call is the while loop. While something is true, do something. Now that something can be a much big complex thing. So my example is like, while the light is equal to red, keep the foot on the brake. Well, if you're sitting at a red light and that light's red, you want to keep your foot on the brake. And when the light is not red, you're going to probably do something else, which would be the next line in the program, which would be a procedural type program. You go from one line, and then when you get done with that one line and you move on to the next one, you execute what the next line tells you to do. That's one type of loop. Another type of loop is the for loop. The for loop isn't that terrible either. It says, okay, for, I'm going to set a value of a variable that I define equal to a value. And I'm going to keep incrementing it every single time I do this loop until I get to another value. Well, what does that really mean? It means I say I want to do something 5 times. For variable equals 1, continue on until variable equals 5. Increment the variable every time you execute the loop. And when you get to 5, go ahead and stop and move on. That's called a for loop. It is not a challenging concept. It is really actually quite easy. If I told you go up that set of stairs 5 times, okay, you couldn't do it. Reason? Because I didn't tell you to come down. Remember, computer programming languages are literal. But if I said, go up the steps and come down the steps 5 times, after you executed the first up and down the steps, you would be back where you started from, and you could go up and down the steps again. Also, a reason why many people have a very difficult time with programming is because they have this expectation that computers are human and will understand what they're trying to do when they're telling them to do something that is absolutely impossible to do, unless you imply things into it that aren't necessarily implied to a computer. For example, if I told you to go up that set of steps 5 times, you would probably go up and then come back down and do it again. Well, that's because you're smarter than a computer. I know it sounds funny to say that you're smarter than a computer, but another reality is computers are not smart. They are complete and utter idiots. They can only do exactly what you tell them to do. The fact that they can do it quickly doesn't make them smarter. It just makes them a faster idiot. They still need to be able to go, be told exactly what to do. So this is worth remembering when you're a computer programmer. And yelling at the computer and complaining at the computer that it's not doing what you want to do, it's not the computer's fault. It's your fault because you didn't specify in exact terms what it is you wanted them to do. And that's where at the end of what we're going to talk about with loops. Let's talk functions. Functions are great things too. And now we're actually getting into something that's a more complex and abstract concept. Loops, if-thens, those are pretty simple things. Amazing what you can build with those things. All the stuff that you ever see computers do, including artificial intelligence, is nothing more than an assignment of variables and a series of if-then statements and loops. It's all it is. It's just very complex ones. Okay, functions, add this new capability to here, is I now have the ability to take things that I want the computer to do, and I can wrapper them into a ball, and I can give that ball a name. Wow. Well, what's the great thing about that is that when I wrapper it into that ball and give that ball a name, I can call that ball, I can send information to that ball, and it can send information back. It's still a ball of information, but it lets me reuse that ball in a lot of different ways. So that is the basic concept behind a function. But remember this, I can define a function, basically to say what's going to go inside the ball. I can call a function, basically I can say, ball, do your stuff. I can give information to the ball to give it specific instructions of how to do its stuff. And the ball can return stuff to me after I tell it to do its stuff. Whoa. That makes this powerful. Now, that's it. you get those basic concepts of computer programming down, you truly understand these base concepts and learn the syntax of computer programming, you can write nearly any program. In fact, I don't really think of too many programs you can't write. Now, there are lots of other things in programming languages that make the use of these things much, 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 much easier. Okay? So in other words, that concept of reusing and encapsulating, those are great things. But these basic concepts are where you start. You absolutely must understand these things, or you will not be able to be a computer programmer. This is the fundamentals. Now, to be a great computer programmer, you're going to move beyond the fundamentals. But the basics are right here. You must understand these things. I hope this is helpful to all you folks out there that are thinking, I'd like to be a computer programmer. I want to learn how to do this, because here's the great thing about being a computer programmer. One is, we'll spend 40 hours solving a 10-hour problem that we only want to solve one time. In the long run, we save ourselves a ton of time because we've solved it one time so that it can be reused every time the problem occurs. That's just the nature of computer programmers. Computer programmers typically are relatively lazy because we don't like doing things over and over again. It's just the nature of the beast. But we're capable of taking anything that you do, anything that needs to be done, and breaking it down into every individual step and part and piece. And a great computer programmer can do that at an amazing level. Programmers, as they're getting there, are the people that are getting to become great programmers, are those people that are learning how to break something down into its smaller and smaller pieces, and understanding what actually happens when you tell the computer to do a specific act. Those side effects that you weren't actually thinking of in your head. Really great computer programmers do think of those things in your head. When you develop a whole list of instructions to do some complex task from a bunch of simple instructions, you've developed something. You've developed what we call an algorithm. And that right there is the start of becoming a great computer programmer. I hope this is helpful to you as you think about this whole idea of programming, but this is the whole, what I wanted to get to everybody to understand. This is where we start. You understand this, you're good to go. Great programming. I hope that you will continue on with all my other programming related lectures, and I'll see you out there in the cyber world. Bye.